Hello all, welcome to your channel DIY Community. Please subscribe to this channel and get access to exclusive content and resources. You will also become part of our DIY community where you can connect with like-minded individuals and receive support. Hi there. In the previous video, we have seen how to set up our environment to design our simple server. So this simple server is going to be a distributed component. In the previous video, we have downloaded Visual Studio, we have downloaded Boost, and we have set up all the configurations which are required to design our server. Now, before we start, the scope of this tutorial is not to go over network architecture. I'm assuming you already know that. In this series, we are going to design and develop real-life practical application of network connected components. These are also called distributed applications. These distributed applications communicate with each other using TCP or UDP protocols. Now, the choice of TCP or UDP depends upon what exactly you're trying to achieve. If you are designing a component where the speed and efficiency is important, then go for UDP. For example, if you are designing streaming media, DNS, or Internet of Things, go for UDP. But if you're designing a component where reliability is important, then go for TCP. For example, file transfer protocols or email servers and those kind of stuff. Let's see an example now. So this is a sample application. It's a very simple, very basic application. So in this application, we are trying to create a TCP client which will perform a connection with a server. Now, to keep it simple, I'm not going to create a server. We will try to connect to an existing server on the web. Now you can see that we are using ASIO library and some other headers from Boost. So the first object which we will create here is error. So error is a specialized object from Boost which is used to handle various kinds of error codes which you can encounter while designing your application. Now, to keep this program simple and focused, I'm not going to do too much of this error handling. But if you're writing a very professional program, you got to take care and you have to write error handling wherever it is necessary. So the second object, which is very important here, is IO context. In the previous, if you're using an older version of Boost, you might see IO service, which is almost similar. So if you're using a new version of Boost, go for IO context. So what exactly is an IO context? So IO context is a core component of asynchronous input-output. This IO context provides an interface for handling input-output events such as socket operation, timer events, and signal events in a platform-independent manner. At this stage, I'm not going to go into too much detail of IO context, but one thing you will have to consider is don't make copies of this IO context. If you are using a function and if you have to pass it as a parameter, use shared pointer. Next object which we are going to use here is endpoint. Now, what is endpoint? Now, in endpoint in computer networking is a unique combination of IP address and a port number. So basically it's an address, right? So what is an address? Address is a unique combination of IP address and port number. That's all at this point of time. And then there are a lot of interface functions which we can use to resolve DNS and to use IP address and so on. So at this point of time, just go with this one. So the next important object which we'll be using here is the socket. So in the socket, you have to pass a IO context. So once your socket is ready, try to use it. Now use this function connect by passing the endpoint and error. So if your socket gets connected properly, then obviously you'll not see any error. And if it gets connected correctly and everything is good, if you're done, then final thing is, once you process your information, just close. Now let's test this application. So I will compile it. Okay, cool. So you can see that it is connecting to one IP address and the connection is good. So the next test we will do is we will convert this application to use it as an HTTP client. So what is an HTTP client? It's nothing. It's just a client which will send an HTTP request to a HTTP server. Now, what is an HTTP request? You can Google it. It is not that simple. It's just a protocol, message protocol, which an HTTP server can understand. For example, in this case, I'm sending a GET message, HTTP version 1.1, and I'm trying to connect to this website, Columbia ASIO. So let's see this. Okay, compiled. Yeah. So we sent this request and this is the response we got. So basically it means that website to which we are sending an HTTP request, it already got moved to HTTPS. Obviously nobody uses HTTP nowadays. So if you are using a sophisticated browser, so what your browser will do, so your browser is a client. So browser will send this HTTP request and to this server, this particular place, and the server will give a response back to the client saying that, oh, my HTTP doesn't exist anymore. I already moved to HTTPS and this is my new address. So browser will interpret it and it will send a new request, HTTP request, to this location. Now because our client is not that sophisticated, so it is simply printing the message and it is stopping there. So this is how you can design a HTTP or basically a TCP client using Boost. So what extra we did in this HTTP client? So in HTTP client, we are using a function called write. Now, if you have time, go and explore this library. It's a very interesting library. There are hundreds of ways you can send a message and receive a message. So I'm using a very basic function here called write. So what this write is doing, it is taking a socket and it is sending your request by transforming it into a intermediate object called buffer. So just pass your string here and it will get converted to buffer, which will be used by write. So just for timing, ignore wait, don't worry about it, but just to keep it simple, sometimes when a server is, there is a delay on the server side to generate the message, we have to insert some delay over there. So the client will wait for until it gets a message. Then we are using this available to count how much message or how many bytes of messages a message is available on the socket, and then just read whatever it is there and print it. So the functions which we are using here is wait, sorry, not wait, write to write to the socket, and we are using read to read from the socket. So this is how you can design a simple TCP client. So this application is a very straightforward application, just line by line, incremental. The same thing you can also write in like more sophisticated C in the form of a class. So let's disable it. I'm disabling this code in my application, and I will enable a different one. It is exactly similar, but it is more object oriented. So this is a TCP client, which is an object oriented version of the previous program which we have discussed. So I have disabled the default constructor here because I didn't want to make my program more complicated. If you choose to enable it, then you'll have to provide other interface to set other parameters. Here I just try to make it very simple. I'm providing IO context, I'm using shade pointer for it, I'm providing IP address, and I'm providing port. And once the socket is ready, I'm opening it, and then there is another function here to connect. So connect, in turn it will simply call sockets connect interface with endpoint and error. Then there is another interface here which will get the request from the user, and it will process it and it will send the response. So basically it is taking the request and it is using sockets write interface, and it is providing the request to the web server, and whatever response it gets, it is reading it and it is returning back to the user. So there's a destructor. I'm closing and shutting down the socket in this place. I'm not handling any exception, but if you want to do it, please do it. I have created member variables to store the socket, endpoint, and IO context. So again, I'm using shade pointer for IO context, which is very important. Now in my main program, I'm making a shade pointer of IO context and creating an instance of TCP client, and I'm passing IO context, IP address along with the port. And once the client say connect, and after that, if you send a request, the request will be forwarded to the web server, and whatever the response, you'll get back, and you can print it. So it's a very simple TCP client. Just to keep it simple, I didn't introduce any complexity here, but if you want to make it like more professional, you can explore the library, and you can do whatever is required on your end. So that's all for today, guys. Hope you enjoyed it. Thank you for watching. Thanks for watching. Please subscribe to get more professional advice. In addition to our free online content, we also offer free online classes for students. These classes cover a range of topics, and they're designed to help you enhance your skill and knowledge. We encourage you to join us and take full advantage of this opportunity to learn and grow.